Okay, we started. Yeah. Good morning, ladies and gentlemen. Welcome to the parallel session at the International Conference on Advancement in Data Science, E-Learning, and Information System, or ICADEIS 2025. My name is Reicka Sofi Azura. I'm honored to serve as a moderator for this session. And today we have a series of remarkable presentation that will explore in data science for health one. For example, I and healthcare asset. Before we begin, allow me to outline the format for this session. I will tell the general rules for the presentation. Okay, everyone, I'll listen for this general rules. Each presenter will have a maximum 10 minutes to deliver their presentation. At the 8 minutes, there will be a reminder that there are 2 minutes left. At the 10 minutes, I will state that time is up. Okay? And follow it by 5 minutes of question and answer or Q&A segment. For online session, a maximum of 15 minutes per presenter for Q&A session, but can be extended to 20 minutes if needed. Yeah. I kindly ask all attendees to hold their questions until the Q&A session after each presentation. If a presenter is not ready to present within 1 minute of their scheduled time, we will proceed with the next presenter. And the presenter who was not ready will be rescheduled to present at the end of the session after all other presenters have finished. And during other presenter sessions, please mute your microphone and unless permit to speak. This is regulation is for all attendants, yeah? Does everyone understand the rules? If have understood, we will continue to the next session. Or there is question? Okay, if there is no question, we will continue to the next session. I'd like to remind to all presenter to change your display name into your paper ID, followed by your full name. For example, paper ID 157681131 underscore Reicka Sofi Azura. Okay, make it like this. I will check it for all the presenter display name. Okay, while we waiting, please make sure to use official background, virtual background, provided for this session. This helps maintain a consistent and professional appearance throughout the event. Okay, I will check it first for all the presenter display name. Okay, I have checked it for all display name all of the presenter. I have made you all have made correctly, and also for this virtual background. virtual background. Please please turn off the screen video for all the presenter. I will check it one by one. Okay. Make sure all on camera ya. For presenter Eric. And okay, Eric have done. Okay, all done. Okay, great. Thank you. We will move on the next session. Before we start, we have a photo session first. Make sure all in the camera. Yeah. Co-host ready for capture? Okay. Okay, we start photo session ya. Okay, are ready for all? Yeah. Okay, 2 times photo session. One again. Okay, already co-host? Okay, thank you. Okay, first of all, I want to take the attendance for all the presenter who are present in this room. Okay. The first, Tabina Safa Nabila Syahda. It's already there. With the paper under the title, A Comparative Study of VGG 16 Mobile Net and Ensemble Method on Fundus Image-Based Cataract Detection. That's true? And for the second, Iga Novinda Rantaya with the paper Leveraging Former for Precision Segmentation of Optic Cup and Optic Disc in Fundus Imaging for Glaucoma Detection. And the third, Eric Silvanus Haryanto with the paper Privileging Eager Learning for Retinal Abnormality Classification with Local Binary Pattern Features. And the fourth, Muhammad Fahmi Hidayat with the paper Object Detection for Occluded Medical Equipment in Hospital Environment using YOLO VH. And the last, Fauzan Ihsani with the paper Modified Carbonen Formula and SMOTE LSTM for cycling post monitoring with imbalance HAR dataset. That's true. Okay, we'll move to the next session. Are you ready, all the presenter, for presentation today? Okay, I think all you ready. Now, without further ado, let us welcome our first presenter, that is Mrs. Tabina Safa Nabila Shahda, with the paper A Comparative Study of VGG16, MobileNet and Ensemble Methods on Fundus Image-Based Cataract Detection. With the authors, Tabina Nabila Shahda from Telkom University Surabaya, Indonesia, Muhammad Nizar Palevi Madi from Telkom University Indonesia, Berlian Rahmi Lidiawati from Telkom University and Institut Teknologi Telkom Surabaya, Indonesia. Okay. Please join me in giving a warm welcome to Mrs. Tabina. Mrs. Tabina, are you ready?
Yes. Can I have?
Please
Can I
unmute
ask question?
first to speak. Are you ready?
Yes. Yes. Can I ask question? We must presentation or we can play video?
Yeah.
We can play video or we must presentation?
I'm sorry, it's not clear. Can you repeat, Mrs. Tabina? Okay, Mrs. Tabina, if you are ready, you have 10 minutes for presentation, and the place and time are welcome. Please.
Hello everyone. Let me introduce myself. I'm Davina Safana Gilashahda. Today I will be presenting our paper with the title A Comparative Study of VG16, MobileNet and Ensemble Method on Fundus Image-Based Cataract Detection with the author me, Tabina Safana Gilashahda, Muhammad Nizar Palevi Madi, and Berlian Rahmi Lidiawati. This paper is motivated by cataract are the leading cause of blindness in the world. To detect cataract, there is a widely used method other than slit lamp, which is to analyze retinal fundus image. However, there are several challenges associated with using fundus image to detect cataract. First, the detect process is still done manually by doctor check. Secondly, a highly experienced ophthalmologist is required to assess the diagnosis reliability of fundus image. The challenge of using fundus image can be overcome by the application of convolutional neural network, which can process image for classification. In this paper, we will compare CNN model by implementing approaches such as ensemble learning and hybrid method to find the most optimal model for classifying fundus image. To deepen our understanding, we conduct a literature review. The first point is application Figgy 16 versus MobileNet. Sharot conduct risk detection experiment using Figgy 16 and MobileNet model. This comparison highlights the importance of selecting a model based on the application's specific needs, whether prioritize accuracy or computational efficiency. The second point is improvement in ensemble and hybrid method for CNN model optimization. Combining the two models is believed to increase the accuracy value. Azura unified several CNN models into one new model accompanied by a hybrid method. The method used is a hybrid convolutional and recurrent neural network method. In the methodology stage, the fundus image dataset was pre-processed using the Clahe contrast limited adaptive histogram. As you can see in the slide, this is the different before and after process Clahe method. The Clahe method, the technique to image contrast. After Clahe method, we divide dataset into two subsets. The first is normal and the second is cataract with a total 1000 data. The model development utilized a base model with Figgy 16 model and MobileNet model as the base model used. From that model, we combine with ensemble and hybrid method, and we have 6 models. The first is Figgy 16, MobileNet, Figgy 16 and MobileNet, Figgy 16 and SPM, MobileNet and SPM. The last one is Figgy 16, MobileNet, and SPM. Oh, sorry. All model we will evaluate with metrics accuracy, precision, recall, and F1 score. Result of this study using the hybrid parameter across the model with the configuration learning rate with value 0.001, activation function with value sigmoid, batch size with value 32, optimization function with Adam, and dropout with the value 0.5. In the right table, we can see the MobileNet has the highest value for accuracy, recall, and F1 score. Meanwhile, for model MobileNet and SVM has the highly value for precision. To simplify the final result, we calculate the average accuracy, loss, and Pearson correlation. From this, it was determined that MobileNet has the highest correlation accuracy with the value 0.7355, and Figgy 16 and MobileNet model has the highest score to average accuracy, average loss, and correlation loss. From the picture, we can see the difference between application SVM and not application SVM. The use of SVM as a hybrid method with CNN makes the trained model less prone to overfitting. This study shows that the application of SVM to ensemble learning model offer the potential to achieve better accuracy and precision and offer better machine learning on MobileNet model. Conclusion from this study is that ensemble model perform the best with the highest average accuracy value of 0.9377 and average loss value of 0.2085. As for the model that can learn well, MobileNet is seen from the highest accuracy correlation value with value 0.7355. However, the study found that there is overfitting in the model, even though it was a fairly high accuracy value. In the future, we intend to improve accuracy and minimize overfitting for classification model using hybrid method with larger and more diverse dataset. Maybe enough for my presentation. Thank you.
Okay, thank you, Mrs. Tabina, for the insightful of the presentation. Okay, we will now open the floor for the question. If you have a question, please use the raise hand from the feature in Zoom and kindly state your name and affiliation before asking your question. Is there any question from the attendants? Like, if there is no question, I will asking one question for Mrs. Tabina. Mrs. Tabina, can you explain the importance of this concept in the context of the future career? Okay, please.
The important is because to detect cataract, we can use other method other than slit lamp, which is to analyze retinal fundus image. Why we can using fundus image? Because if we detection with slit lamp, the challenge is detection still processed manually by doctor. The second is highly experienced ophthalmologist is required to assess of diagnosis fundus image, and maybe other doctor have the different diagnosis. That's why from this research we contribute make model CNN to help doctor for analyze fundus image for cataract.
Nice. Thank you for the answer. That's a good answer. Thank you very much for Mrs. Sabina. Okay, let us now proceed to our next presenter. Okay, for the next presenter, please welcome Mrs. Iga Novinda Rantaya.
Okay.
Mrs. Iga Novindarantaya will present paper under the title Leveraging Segformer for Precision Segmentation of Optic Cup and Optic Disc in Fundus Imaging for Glaucoma Detection. That's right?
Yes,
Okay.
that's right.
Okay, with the authors Iga Rantaya from Universitas Universitas Gadjah Mada Indonesia, Syukron Abu Ishak Al-Farazi, Universitas Gadjah Mada Indonesia, and Hanung Nugroho, Universitas Gadjah Mada Indonesia. Warm round of applause for Mrs. Iga.
Thank you.
You have 10 minutes for presentation, and place and time are welcome.
Okay, thank you for your attention. My name is Iga Novindarantaya, and I'll present my research is leveraging segformer for precision segmentation of optic cup and optic disc in fundus imaging for glaucoma detection. So here the content list that I present today, the introduction, related studies and contribution, research methods, and the last one is experiment result. Okay, the first introduction, so a little bit about the glaucoma. So glaucoma is a major cause of blindness worldwide. In 2020, approximately 76 million people were affected, a number projected to reach 111.8 million by 2040. So detecting glaucoma early is very, very crucial, and it relies on accurately measuring cup to disc ratio, or we know as CDR. This is requires segmentation of optic cup and optic disc in fundus imaging. As you can see in the right images, optic disc in the blue one and optic cup in the green one in the smallest circle in the middle. And the challenges is manual segmentation, however, is time consuming and prone to error, which is where automated methods can make a difference. So our solution, we explore the use of vision transformer model, segformer, to improve accuracy and efficiency in this segmentation task. Next, related studies and contributions. So here are some research that have been found until this presentation. There are some another vision transformer model is being used to segmenting OCNOD, which is the highest one or the highest die score is using swing transformer on the first journal is 94% for optic cup and 85% for optic disc. So our contribution is introducing segformer for precise OCNOD segmentation, enhancing computational efficiency without data augmentation, and evaluating performance on the diverse SMDG19 dataset. Next, research method. So here our research method, there are four process in our research method. The first one is data collection. So in this research, we're using data set called SMDG19, which is a combination of 19 public data set like Origa, Papilla, and Review, like that. Next, the process is data filtering, so only image with valid segmentation label included. So for total, it's 12,000 data. We using 2,000 retinal fundal image with complete OC and OD labels. And the third process is modeling. So in here we're using segformer with reduced input resolution and pretain weights with ADA 20K. So this modeling will be explained in the next slide. Next, the model evaluation, I'm sorry. So in here we're using die score, is measure overlap between prediction and the ground truth. So it's a little bit about the
S.Kommer overview. So S.Kommer is a vision transformer model designed for semantic segmentation. So there are key features of S.Kommer. The first one is transformer encoder. It's capture global context by dividing images into patches with detailed processing. And MLP decoder, it simplifies segmentation without complex post-processing. But its efficiency, its high accuracy, and significantly reduce computational time. And this architecture has advantages. It can handle varying object size and shape with minimal pre-processing, can make it faster and suitable for real-time application. So this is the parameter setup that we use in this work. The first one is model. So in here we're using S.Kommer B3 models. And then we're using input resolution. We reduce to 128 by 120 pixel. It's for computational efficiency. And for the training setup, using early stopping, it's to prevent overfitting, and model checkpoint to save best performance model based on validation loss. And for the evaluation metric, in here we're using die score is for accuracy of segmentation. Okay, next our experiment result. So here our experiment result on SMDG19 dataset. As you can see in the table 1, the best model is on model SGF04 is 45 epoch. It's got highest die score 94% for OC and 90% for OD, which is has training time 7 hours. It's significantly faster than other models like Vanilla Vision Transformer and Swing Transformer. Segmentation speed. So for segmenting 6 image, it just need 0.34 seconds. So it is very, very faster. Next, we also compare our work with previous work. As you can see on the table 2, it's comparison with different method on review. And the table 3 is comparison with different method on Origo. So this comparison is based on benchmark on another data set. And as you can see in the two tables, the S.Kommer is outperform several state-of-the-art vision transform model in the task of OC and OD segmentation. Okay, the last is conclusion. So S.Kommer is demonstrated efficient and accurate OC and OD segmentation and strong potential for clinical application in early glaucoma detection. And for the future work, we can evaluate performance or on additional dataset and real-world clinical scenario. And we can also develop hybrid approach to further improve segmentation accuracy. That's all for me. I'm happy to answer any question you may have. Thank you.
Okay, thank you very much for Mrs. Iga for that wonderful presentation. We will now open the floor for a question. If you have a question, please use the raise hand feature in Zoom and kindly state your name and affiliation before asking for the your question. Is there any question?
Moderator, please, I want to ask.
Yeah, please.
Okay, thank you for Miss Iga. I have some question. How does the S.Kommer model improve the efficiency and accuracy of optic cup and optic disc segmentation in fundus image for glaucoma detection compared to other vision transformer based models? Okay, thank you.
Okay, thank you for the question, Mrs. Nur Ayu. And Mrs. Iga, would you like to address this question?
Yes.
Okay.
I'll answer it. Thank you for your question, Miss Ayu. Nur Ayu. Okay. How does the stack former model improve efficiency compare with another fission transformer based model or another fission transformer architecture? So this comparison is the first one is based on the dataset benchmark, so it's not the answer. So maybe we're gonna take back to the related study. So here's some another fission transformer method have been used to segment OC and OD, which is the best one is fission swing transformer model. We got die score is 94 and OC from OC and 85% from OD. So a little bit about this journal. This journal is from Elsevier on 2024. So this journal is about the OCNOD segmentation also using the fission transformer architecture and how they are training their model. So in here they are using augmentation when need 30 more than 3 hours to training time. So how does the segformer model improve the efficiency and accuracy? We're gonna compare it to the my research. So here our best result. So the first one is I know that this comparison is not apple to apple because data set that we're using is very different. So in here we're using SMDG19 and the author is using it's like 5 or 4 combined data set like that. So how does the segformer improve? The first one is about the score. So we got the highest score than the author, where our die score on optic up is 94 and optic disk is 90. And the second is about the computational time. So our training time is just 7 hours. It's very, very faster than Swin and vanilla fission transformer where need more than 3 hours. And the number 3 is because we're not using augmentation. We're not using augmentation, so we can say our model is best on generalization better than a swing transformer. And the last one is segmentation speed. So we just need 0.34 second to segment 5 image. It's very, very faster. And I think it's good for clinical use. That's all for me. Thank you.
Okay, thank you very much for the answer, Mrs. Iga. Is there any else question from the others? Time is up. If you have additional question, we encourage you to approach to Mrs. Iga during the break session. Yeah. Okay. Thank you very much for Mrs. Iga. Okay. Now let us now proceed to our next presenter.
I'm sorry, miss, you are in mute right now.
Oh, actually, I'm sorry. Yeah, I'm starting again. Okay, thank you very much for Mrs. Iga for the answer before. Okay, now let us proceed to our next presenter. The next presenter. Okay, the next presenter, please welcome Mr. Eric Silvanus Haryanto with the paper under the title Leveraging Eager Learning for Retinal Abnormality Classification with Local Binary Pattern Features. A warm round of applause for Mr. Eric Silvanus Haryanto. Mr. Eric, are you ready?
Hello. Yeah.
Hello. Okay, you
Hello.
have 10 minutes for presentation.
Good
You have
morning, everyone.
ready?
Yeah. Good morning, everyone. My name is Eric Silvanus Haryanto. Today, I
Okay.
want to present my paper with the topic Leveraging Eager Learning for Retinal Abnormality Classification with Local Binary Pattern Features. I work this paper with my partner, Benny Chandra Setiawan, and with my supervisor, Mr. Semen Yuda Prasetyo and Mr. Eko Setio Purwanto. Here are my content lists, which I'm going to present today. The first one is introduction, followed by methodology, then results and discussion, and finally conclusion. Traditional methods for diagnosing retinal abnormalities often rely on manual image analysis by ophthalmologists, which can be time-consuming and prone to human error. But the advent of computer-based image analysis has brought significant advancement in ophthalmology, providing efficient and accurate methods for detecting and diagnosing retinal diseases. This paper investigates the integration of local binary pattern features with eager learning models for the classification of retinal abnormalities, focusing on diseases such as diabetic retinopathy and age-related macular degeneration using the retinal OCT image dataset. Here are the example of the dataset's image, which we classify into 4 classes of disease: normal, CNV, DME, and Drusen. You can see the name on below. And here's how I proceed with the test. Number 1, pre-processing, where in this step we resize or rescale the image so it will be similar to each other, which also it will be easier for the machine to run. Then we proceed to local binary pattern feature extraction. Here we let the machine to understand the structure of the image like edges, spots, to describe textures on the image by looking at patterns of light and dark areas around each pixel. And then we proceed to model training, which we use eager learning, such as decision tree, random forest, logistic regression, and neural networks. Lastly, we evaluate and compare to find the best model. Here is the table of the experimental results of my local binary pattern extraction into the eager learning models, which we can see random forest has the highest compatibility with the datasets we are using. Logistics regression has a really low accuracy because it is a linear model, which is difficult for image classification. Also, neural networks has a really low accuracy because it is an eager learning that requires high quality data, since the datasets we are using has a poor resolution and blurriness. In this study, we explored the integration of local binary pattern feature extraction with eager learning models to classify retinal abnormalities using retinal. Oh, sorry. Conclusion. While logistic regression struggled due to its linear nature and neural networks face challenge with the low-quality datasets, this highlights the importance of selecting models suited to the dataset's characteristics. The finding emphasized the potential of combining texture-based feature extraction like local binary patterns with machine learning models for efficient and accurate retinal disease classification. Future work could focus on improving datasets equality and exploring advanced feature extraction techniques to further enhance performance. That's all for my presentation. Thank you.
Okay, thank you very much, Mr. Eric, for that insightful presentation. We will now open the floor for the question. If you have any question, and please use raise hand feature in Zoom. And kindly state your name and affiliation before asking your question. Is there any question? If there is no question, I will ask for Mr. Eric. I will ask one question. Is there any current debate or controversy related to the topic? And what are the ethical considers related to the topic, to your topics?
Sorry, what do you mean by
get
ethical
the
consider?
question?
No.
Okay. Okay, I repeat it. Is there any current debate or controversy related to your topic?
Only no.
No. And what are the consideration related to topic?
For improving the retinal. Sorry, wait a minute.
Okay, I will write.
It's more for here because the images are not that accurate. From this paper, we suggest that future works can fix the accuracy for their machine learning, so it can be more accurate for hospital world. That's all.
Okay, thank you very much for the answer, Mr. Eric.
Sorry, you're muted.
I'm sorry before. Okay, we'll continue. Okay. Thank you very much for Mr. Eric for the answer before. And let us continue to the next presenter. For the next presenter is Muhammad Fahmi Hidayat with the paper Object Detection for Occluded Medical Equipment in Hospital Environment Using YOLO VH. With the authors Muhammad Fahmi Hidayat from Telkom University Indonesia, Sinung Suwakanto, Telkom University Indonesia, Fakih Hamami, Telkom University Indonesia, Anis Farihan Matrafei, University Malaysia Pahang Al Sultan Abdullah Malaysia, and Eddie, the University of Western Australia, the University of Western Australia, and Harry Perkins, Institute of Medical Research Australia. Please join me in giving a warm welcome to Mr. Muhammad Fahmi Hidayat. Mr. Muhammad Fahmi Hidayat, are you ready?
Okay, ready.
Yeah, you have 10 minutes for presentation. And place and time are welcome.
Okay, good
Please.
morning. Good afternoon, everyone. My name is Muhammad Fahmi Hidayat. I'm from Telkom University. Today, I want to present my research with title Object Detection for Occluded Medical Equipment in Hospital Environment using YOLO version 8. Okay, so in this content list, we have the introduction and then related studies and contribution, research methods, and experiment result. In here, for the introduction, it is efficient detection of medical equipment is vital for ensuring smooth hospital operation, where like inventory tracking and patient safety and resource management. However, for the traditional object detection, it's often struggle to identify partially visible items in clutter and dynamic hospital environment. So this limitation result in reduced accuracy and reliability, particularly when faced with occlusion challenges that are common in healthcare setting. Where the picture crowded hospital room is filled with various medical devices are partially obscure or not fully visible. So this research focus on leveraging YOLO version 8, an advanced deep learning model to improve the detection of medical equipment under various occlusion conditions. By incorporating enhanced feature extraction and attention mechanism, YOLO version 8 offer superior accuracy and robustness compared to traditional approach, where this finding demonstrates the potential of YOLO version 8 to revolutionize the hospital asset management by providing reliable detection capability in even the most challenging environment. So we have three goals, where the one is develop a detection system that maintains high performance across diverse hospital environment with varying level of clutter and lighting condition. And second is provide a reliable solution for tracking and managing hospital asset, ensuring resource availability and minimizing losses. And third is address to limitation of traditional methods by improving the model's capability to identify partially visible objects. In this contribution for this research makes a significant contribution to object detection in hospital environment by developing a custom data set where with under various occlusion level in 30 until 50% and environmental scenario such as like a different lighting and clutter condition. The YOLO version 8 model was enhanced with advanced attention mechanism like CBAM to improve feature extraction for occluded YOLO object and optimized using techniques such as CIOU and focal loss for better detection performance. So this is for the methodology. First, we got to collection dataset. This step involves like gathering the necessary dataset of images for training the YOLO version 8 model, where the dataset is up to 5K. And then second is processing dataset. The collected dataset is preprocessed, which may include tasks such as resizing the image, normalizing pixel value, and applying data augmentation technique. So number 3 is a configuration model. The YOLO version 8 model is configured with appropriate parameter and setting to prepare it for training, where the epoch is 100 and image size 6040 and batch 8. And the fourth is a train model. The preprocessed dataset is used to train the configure YOLO version 8 model in 5 hours. And 5 is evaluate model, and number 6 is safe model. So the research method where the dataset preparation like a custom dataset, where by collecting and labeling images of various hospital equipment where operation level in 30 until 50%, and model training, YOLO version 8 was utilized as the best model, leveraging pre-trained weight for transfer learning, and the evaluation metric is the model's performance using precision, recall, accuracy, and F1 score. For the comparative analysis, YOLO version 8 is performance was compared with detection models including faster RCNN, SSD, MobileNet, and CenterNet. The analysis highlight YOLO version 8 a superiority in accuracy and speed, particularly for real-time application. Where the experimental result in here comparison with faster RCNN, SSD, CenterNet, and efficient DO. For the table, YOLO version 8, where the confidence in R78 and F1 score is in 88.9. Sample where experiment result, and then for performance on unobstructed equipment, the YOLO version 8 model achieved an impressive F1 score and accuracy 0.938 when detecting fully visible medical equipment, where in performance under occlusion despite like 30 and 50% occlusion, where the model maintains strong detection performance with F1 score in 0.889 and accuracy of 0.867, where the confidence score decreased from 0.896 unobstruct to 0.76 in occlude, reflecting the model's sensitivity to visibility constraint while maintaining robustness. Where the comparison with other model, YOLO version 8 outperformed faster RCNN, SSD MobileNet, and CenterNet. It achieved the highest F1 score in 88.9% and confidence in 76%, highlighting its advantage in accuracy and robustness for detecting occluded object in real-time scenario. So for the future research dataset enhancement like various hospital environment and lightning condition or diverse medical equipment types, complex and irregular occlusion patterns, and dynamic scenario. So in system integration, maybe like develop standardized APIs for a hospital system and create real-time inventory tracking workflow, integrate with predictive maintenance system, and implement equipment usage pattern analysis. And number 3 is for the technical improvement, like develop adaptive occlusion pattern recognition, implement temporal tracking for better detection stability, optimize model for its computing deployment. And for the last is practical implication is number 1 is enhanced inventory management, like real-time tracking of medical equipment allocation, automate inventory counts and update, and for the reduced time spent searching for equipment. So second is improve resource allocation, where optimal distribution of medical equipment across department, better planning for equipment purchase, reduce equipment hoarding. And third is cost saving, reduction in lost or misplaced equipment, lower replacement costs, decrease equipment rental needs, and optimize maintenance schedule. And number 4, operational efficiency, streamline workflow for medical staff, reduce time spent on manual inventory check, and faster equipment retrieval, improve emergency response time, and enhance compliance with regulatory requirement. So maybe like that. Thank you for me. Thank you.
Okay, thank you very much for Mr. Muhammad Fahmi for that wonderful presentation. And now we open for the question. If you have a question, please use the raise hand feature in Zoom, yeah? And don't forget to say the name and the affiliation before asking. Wait for 1 minute. There's no question. There is no question related this topic. Okay, if there is no, I will asking for Mr. Muhammad Fahmi.
Okay.
Okay, Mr. Muhammad Fahmi, can you explain the importance of this concept in the context of the future career?
Yes. For the importance future is for where the hospital is very crowded, where the management for the medical asset is very maybe like what misplaced equipment, maybe where misplaced in other place, other room like that. So for the future is for detection the asset management to what ensuring a resource availability and minimize loss the management assets. Maybe is like that the solution for tracking and managing hospital.
Okay. Thank you very much for the answer, Mr. Muhammad Fahmi.
Okay, thank you.
Okay, now we proceed to our next presenter. Actually, this is the last presenter for this room. Okay, please welcome Mr. Fauzan Ihsani with the paper Modified Carbonen Formula Smoothie LSTM, sorry, for cycling post monitoring with imbalance HAR dataset. With the authors Fauzan Ihsani from Telkom University Indonesia, Muhammad Irsa from Telkom University Indonesia, and Aji Putrada, Telkom University Indonesia.
Okay.
Okay, please join me in giving a warm welcome to Mr. Fauzan Ihsani.
Okay. Thank you for moderator.
Yeah, you have
Good.
a turn for presentation
Okay.
and
Okay. I
place
got it.
and time for you.
Okay, thank you for moderator. Good afternoon, everyone. My name is Fauzan Sani, and today I will presenting our research about modified Carbonan formula and smooth LSTM for cycling post monitoring with imbalanced hard dataset. The author is me, Fauzan Sani, Muhammad Irshan, and Aji Gautama Putrada. We are from School of Computing, Telkom University, Bandung. Okay, the content list to our presentation is the first one is introduce and methodology. The third is result. Finally, the conclusion. The first one is introduction. Cycling intensity plays a critical role in optimizing performance and preventing risks such as knee pain, muscle strain, and fatigue. So, monitoring intensity provide valuable feedback, and prior research suggests that cycling intensity can be estimated from body position and movement using human activity recognition, which is HAR. This study focused on developing a cycling intensity monitoring using a smooth LSTM method to address imbalance human activity recognition dataset, utilizing the HARS dataset. The purpose method was a benchmark against RNN and PCAWS models, with smooth was compared with a K-mean smooth and Adasin for handling data imbalance. For the figure one is a accelerometer sensor placement for cycling. The next one is objective to our research. Number one is a smooth LSTM method can provide optimum classification on imbalance human activity recognition dataset. Number two is a smooth method for cycling human activity recognition with optimum average recall compared to K-mean smooth and Adasin. Number three is a modified Carbonan formula to calculate cycling post target based on intensity target for cycling monitoring application. Next to methodology, the data set our research use is the human activity recognition tandem, which is HART from UC Irvine machine learning, and the labels were coded for each activity as 13, sorry, is for sitting cycling, 14 for standing cycling, sorry, and 130 for sitting stationary, and 140 for standing stationary. For the table one is imbalance condition in for cycling dataset label in UC Irvine machine learning to the human activity recognition term. And the figure two is a cycling intention monitoring research workflow to our research use. Next, the technique. The benchmark human activity recognition classification models our research use is LSTM, which is long short-term memory, GRU, which is gated recurrent unit, and RNN is which is recurrent neural network. For the compare oversampling performance, we use original dataset, smooth, ROS, K-mean smooth, and Adasin. The figure 3 is the concept of the smooth, and the right figures is a cycling intensity monitoring research workflow. We next to result to our research. The comparison all three have recall above 0.90, indicating that the handling of the minority label of each model is good. Only LSTM has a precision above 0.90. Finally, the LSTM model has the best accuracy and F1 score of 0.96 and 0.93. LSTM is optimum model for cycling human activity recognition. We have also tested the statistical significance of the difference in the average accuracy of the every model with a t-test. The t-test show that our model average difference has a t-test p-value below 0.5, which means that all accuracy average has a significant difference. For the figure 4 is the human activity recognition method performance comparison for each machine learning, which is LSTM, RNN, and PCA plus AdaBoost. Next, the For the imbalance method comparison, the majority label is a cycling sitting LSTM on the original dataset appears optimal for that label. The recall of the imbalance method are not optimal on the majority label, but better than the original dataset on other label. Smooth is the method with the best recall onto minority label, including the minority label with the smallest ER, which is standing stationary with recall of 1.0. Smooth also the bit key mean smooth and adasin for average recall with a value 0.9979. So, smooth is the most optimal imbalance method for the imbalance human activity recognition dataset. Next, this figure is a cycling post monitoring app mockup with our purpose, which is a modified Carbonon formula. The design cycling post target calculating application using a modified Carbonon formula. This interface displays cycling performance statistic with a focus on heart rate metric. User can set intensity target and monitoring key indicator such as resting heart rate, maximum heart rate, and target heart rate. This will be assess user to achieving their desired training goals efficiently. Finally, the conclusion. This study aimed to develop a cycling monitoring application to set the target intensity and the heart rate and help user find the target cycling post. We use LSTM for human activity recognition on for cycling post, which is sitting cycling, standing cycling, sitting stationary, and standing stationary, and compare it with two state-of-art human activity recognition method, which is RNN and PCA plus ADABUS. We also address the imbalance problem in the cycling human activity recognition dataset by compared smooth with Kimin smooth and Adasin. The test results show that LSTM has the best accuracy, precision, recall, and F1 score compared to RNN and PCA plus ADABUS with the value 0.96, 0.90, 0.98, and 0.94 respectively. Then LSTM plus smooth also has the best average recall compared to LSTM plus Kimin smooth, LSTM plus original dataset, and LSTM plus Adasin with the value of 0.98, 0.94, 0.92, and 0.91 respectively. We have also designed the application to monitoring cycling post and determine the target post using the Carbonon formula. For the future work, we can extend the testing of the model on the real-world cycling data from various demography to strengthen our theorem future. That's all for me. I am Fauzan Zikrisani. Thank you very much.
Okay, thank you very much for Mr. Fauzan for that insightful presentation. Okay, we will now open the floor for the question. If you have a question, please use the raise hand feature in Zoom. Is there any question? Okay, we will wait for a second to the question. If there is no question, I will asking for Mr. Fauzi. One question for you. I think the method this is interesting for me. Can you provide some suggestion for studying this method effectively?
Okay. For well, sorry, once more the question.
Okay, I will repeat. Can you provide some suggestion for studying this method effectively? Because I'm interested with this method.
Okay, for the suggest the method. Okay, there is already paper in the previous work to apply that smooth with LSTM, but no no other paper with smooth LSTM and human activity recognition. So our research apply smooth LSTM to human activity recognition, where LSTM is proven that optimum performance for human activity recognition, while smooth is proven to be optimum the overcoming imbalance because the dataset have a imbalance dataset. In the contribution to of our research is smooth LSTM method then can be provide optimum classification on imbalance human activity recognition. That's all for me.
Okay, thank you very much for the answer. That's supposed to be. I would to learn more about this
Okay,
method.
thank you very much.
Okay. We have the last session. All the presenter have presented all, yeah. So, ladies and gentlemen, this concludes the parallel session. On behalf of ICADEIS 2025, I would like to thank all our presenters for their exceptional contribution and insight. And I would like also to extend my gratitude to all participants for their engagement and to provoking questions. We hope this session has been both informative and inspiring. And please be reminded that the next session will begin at 13 o'clock or 1 p.m. In West Indonesia time zone. We invite you to stay and continue exploring the valuable ideas and discussion presented throughout the conference. Okay, that's all from me. I'm Reicka, Sofi Azura. Thank you once again and have a wonderful day. Bye-bye.
Thank you very much, moderator.